All right, so we'll continue our lesson today with dplyr, okay? And so if you haven't done so already, do install.packages dplyr and load that library up. Okay, and there are a couple functions in dplyr that have the same name as stats and base, and so these ones will mask them, and that's fine. Okay, the verbs or the functions that we will use in dplyr will be these ones: select, filter, arrange, mutate, summarize, and group by. And summarize and group by, these are some really awesome functions, so we want to make sure we cover those. The other ones are also very helpful, but they kind of, well, so all this to say is dplyr just makes your life easier, okay? It is true that a lot of the things that we'll learn today can be done with your base statistics things and the subsetting commands that we've learned. But dplyr just makes it faster and easier in my opinion, and so I think it's worth taking some time to learn. Okay, the data that we will work with today is NYC Flights 13, and it's a data set related to flights that departed from New York City in 2013. So you can do install.packages NYC Flights 13. You know what? I don't know if I have it on my work machine. And then we'll load this library up. And we can take a look at these different tables. We'll take a look at flights. And we will see that there are many flights as far as flights go. So here it is. This is the Tibble form. If you just type in flights, it's the Tibble form. You can see there's 336,000 over 336,000 rows, and there are 19 columns. And what Tibble does is it just shows the kind of the first 10 rows and just the columns that fit on your console screen. And so over here it says variables not shown, scheduled arrival time, arrival delay, all of these other things. And here's the structure of flights: year, month, day, departure time, scheduled departure time, departure delay, arrival time, scheduled arrival time, arrival delay, the carrier, the flight, tail number, origin, destination, air time, distance, hour, minute, and time and hour. Okay. All right, so we are going to deal with this. This is a fairly large table, right? 336,000 rows is a lot of rows, and so we want to be able to work with it efficiently. Okay, and so we will have these four functions. There are more functions in dplyr, but I would say these are kind of the primary ones along with group by, and so we'll learn these ones. Okay, so select is used for selecting variables, and filter is for selecting observations. Okay, so select, you can think of columns, filter is for rows. Mutate will be to kind of combine the columns in new ways to create a new variable. All right, so this is derive a new variable from existing ones, so this is using the command mutate. And then summarize is change the unit of analysis. So right now we have 337,000, or wait, how many rows? Yeah, 336,000 rows. There's one row for every flight that took off from New York City. We can change this to change the unit of observation. So each unit is no longer a flight, but maybe it is a month, or maybe each unit of observation will be a airline, a carrier, or each unit of observation will be the an airplane, the tail number, or the destination, or something like that, or the origin, okay, because New York has a few different airports there. So we can change the unit of observation using summarize, okay, but we'll take a look at each of these. And so select, here you can just type in the names that you want to select. This is still using the storms, but okay, so using the storms data table, this is just an example. I'm not actually going to execute this. You can just say select from storms, and you just name the columns, storm and pressure, right? So this is the same thing as saying subset storms, and you say column names and you give it the column names. But here it's just very simple. You just say from storms, I want you to select the column storm and pressure, or you can also do minus to say I want you to select everything but storm. You can even do wind : date, all right? And so this is a new feature through dplyr. You can't normally type this into R and understand what you're talking about, right? You only use the colon for integers to say like 4, 5, and 6. But here you can say wind : as in wind through date. So if you're looking at the columns, I can do something like select from flights. I want to select from origin through hour, okay, and that will pick up origin, destination, airtime, distance, and hour. So I can just do origin : hour, and it will pick up those. So that's a nice thing that select can do. You can say one column name through the other column. There are also a few other things in here. So we've already looked at the minus to say everything but that value. You can also say select a range using the colon. There's also things like contains or ends with, everything matches. So for example, ends with, let me just show you what ends with. So there are several rows here. We've got departure time, scheduled arrival time. So for here I can say select from flights those that ends with, and we will say time. And it will select just the columns that end with time, which is a nice thing, right? And starts with works in the same way. Okay. So these are some select useful functions with select. Okay. And matches is for regular expressions, things like that. So you have ends with, starts with, to say things like that. Okay. Filter is for selecting rows. And so in this case, you can say filter storm. So this is very similar to subset, but here we are using filter, and all you have to do is you just specify the variable name and a condition. So in this case, with storms, we're using select the rows where the wind is greater than or equal to 50. With any of these other ones, I could say, select the rows where the carrier is United Airlines. So I can do filter, so I should say filter, and we want flights carrier equal to UA. And so here these will be all of the flights from United Airlines, and there's 58,665 of them. Okay. If you want to have multiple filters going on at the same time, you can just add a comma, and it will automatically do things with say and. Okay, so I could say carrier is equal to United Airlines. I can also say month is equal to 1. All right, and this filters just so that the month is equal to 1, maybe to show that it actually did work. I could say month is equal to 2. And there were 4,346 flights where the month was equal to 2, 4,637 where the month was 1. So you can just add more conditions to filter, just separating them with a comma. And the default is this and this. So everything you separate with a comma, filter will basically say and between them. Okay, and I think we are familiar with these logical operators, right? Greater than, less than, or is not missing, things like that, or is in, percent in, percent, all of that stuff. Okay. I mean, you can also put in the and here as well. So filter and select, just different ways to subset. We can, if you pull up filter as far as Deplyer's filter, well, I guess that's all the help for that. You can, if you want to have the ors, you can just put in the or yourself. Okay, comma would be equivalent to an and. All right. All right. So we also have mutate, which is to create new columns based off of other columns. So in this case, we can say create a new column ratio, and to calculate that column, do pressure divided by wind for the storm. So all we're doing is we're doing pressure divided by wind, and we're creating a new column called ratio. And so in this case, for flights, I could do mutate flights, and we'll do departure time versus scheduled departure time, right? So this will be, oh, I guess they've already calculated that column, departure and delay. But, you know, if we want to calculate it ourselves, right, we can call it departure delay without a space. And this would be scheduled departure time, departure time, departure underscore time minus scheduled departure time. Okay, but of course it tacks it on at the end, so we can't see it. So what I'm going to do, so here it creates this table over here, but I just want to look at the relevant columns. So I'm going to feed this into select, and I want to select departure time, scheduled departure time, and we'll have the original departure delay and our departure delay. Okay, so we have departure time, scheduled departure time, departure delay, and our departure delay. And we can see we have some problems with the way we calculated departure delay, because the way we handled it, we're treating 6 o'clock as 600 and 554 as 554. And so if we calculated departure delay this way, we see it looks like we're 46 minutes early, but that's not true. We're only 6 minutes early. So if we were to run mutate this way, where we just did departure time minus scheduled departure time, we would see we are running into problems there. Okay, and so yeah, Deployer uses pipes, and so you can just kind of pipe one thing into another and select just what you're looking for. So there's mutate. Other things you can, once you've create a create a column. So here we've created a column called ratio, and in the same line I can create another column called inverse, which uses ratio. And it's not like, so normally in R, if you tried to do it in the same line, there is an option to create new columns. It would get confused when you call inverse on ratio, because it's going to try to look for ratio in the original data. But Deployer is smart enough to say, you just created this other thing, and I know that's called ratio, and so I can create something called inverse, no problem. Okay. All right, and so there's other functions that we can run in Mutate, such as, we have pmin and pmax, which is element-wise min and max, and we have cumulative minimum, cumulative max, cumulative sum, and cumulative product. So those just keep tacking on operations. And then you've got between and all of these other things, okay? I normally just stick to my simple arithmetic operations, but these are also useful. Okay. These ones over here, these are what we call window functions, which take a vector of values and return a vector of values. So instead of running them into one, we get another vector value. So cumulative sum will return a vector that goes 1, 3, 6, 10, 15, 21, which is a cumulative sum of 1 through 6. Rather than just sum would just take the whole thing and give you one value. Cumulative sum gives you basically a running vector here, okay? And all of these kind of do that. And so you can so for example, we've got cumulative all and cumulative any, right? So cumulative all, so here is, I'll just create a vector here, which will be, I'm going to just do false, 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 true, true, false, true, okay? And so here, if I look at, look at my vector, I have this, and I can do cumulative any of the vector. And so this, it remains false until it hits one of the trues, and then it's true for the rest, right? And then cumulative all is kind of just the inverse of that, right? It's going to stay true as long as everything's true, and as soon as there's one false, it's going to turn the whole thing into false. All right. This is where I think the true power of dplyr comes in, and this is using the function summarize. And I think they just updated it so they'll accept summarize with a Z. So we're used to spelling summarize with a Z in American English, but Hadley is from New Zealand, and so he spells things the other way. And so we have this, okay? So in this case, it's actually, I forgot what. Let me pull up. I think it is useful to use the library EDAWR. Let me do that, and we want to look at pollution. Okay, and let's jump back to where we are. Okay, so what we want to do is we're going to try to summarize the particle amount, and we're going to create the values median and variance. Okay, we could also create mean and whatnot. And so what we're going to do is we're going to just take pollution and say summarize. And so this is the equivalent of saying summarize pollution, and we're going to create two new values. The values are median, which is equal to median of the amount column, and we want variance, which is equal to the variance of the amount column. All right, and so it takes the mean and takes the variance of this column. And so here it just collapses the entire table into one value. Okay, so this is no different than just saying pollution $size amount, and we're asking what's the median of this and what's the variance of this. Okay, at this point there's no real difference here. And of course we can use the pipe form to do this. We can also have it count. We can say n is equal to n, and here we don't have to actually give it the column amount or anything. We can just leave this blank, and it will say, you know, it will tell us how many rows there are. So we can say, oops, n of, so here if I give it pollution amount, oops, no, I guess you just have to do this. No, it doesn't like it. You have to put it in the summarize function. Summarize, and it will say 6. Okay. So I guess n only works inside the summarize function here. All right, and so here it'll say 6 rows. Okay, no big deal. This is kind of what we're used to. We're used to calculating the mean or the sum or whatever, variance, median, all of this stuff. Okay, and of course these are our useful summary functions. We're used to these, mean and summary, I'm sorry, the sum, standard deviation, all of that. You can also do first and last and distinct inside summarize. Okay. So again, summary will take all of the things, all of the values in your table and boil them down to just one value. Okay. Here it says arrange. Okay, well, yeah, sorry. Okay, and so we'll look at the power of summary with group by. Before we get there, I want to just talk about the arrange function briefly. Okay, and so here this is basically just sort. Okay, you can sort by wind speed. So here we're saying take storms, and we want to basically sort them. We're going to sort them using wind speed. So here we arrange wind into increasing order. Okay, you can say descending on wind, and it does it in descending order. Okay, so no problem there. If you have ties, you can give it a second column to say arrange it by wind and then on date. Okay, so here prior to having a tiebreaker with the 45, it just arranged them in the same order that it appeared over here. And here we can say break it on this tie. Okay, and we're used to seeing the pipe thing. Okay. And so with pipes, we can do all of this. We can say take storms, feed it into select. We can feed it into filter. We can say take storms, run the filter so we are only getting those with wind speeds greater than 50, and then select only the columns storm and pressure. And you can further do this. You can do storms, create a new column called ratio, and then select the storm and the ratio. Okay, so what's this going to produce? It's going to produce a column, a table of just 2 columns, the name of the storm and the ratio. And if we want to sort this based on ratio, we would just pipe this thing into arrange ratio. Okay, Control-Shift-M is our shortcut for the pipe. Okay, let's talk about the unit of analysis. So generally when you start with a table and you run summarize into it, it's going to take all the rows, summarize it down to 1. Okay? What if we wanted to say, I want to summarize those for New York, those in London, and those in Beijing? Okay? Before dplyr, how would we do something like this? Huh? Yeah, you'd have to do some kind of apply. You'd have to split your table up into things via different criteria. You'd have to split it up based on the city, and then you would apply these summarize functions, and then you'd have to combine them. Okay, and so this is what Hadley calls the split, apply, combine. And group by and summarize makes this very, very easy for us to do. And so by showing you, I almost feel bad showing you dplyr right off the bat because you won't get to appreciate how awesome dplyr is until you try to do this yourself without dplyr, okay? And now that I'm so used to using dplyr to do this, I'm trying to think, you know, how did I do this before dplyr? And I'm scratching my head, and I'm sure if I had to do it now, it would be just a big mess to do. But anyway, we can take this table, we can split it based on city, okay, or what we call group by, okay? So we're going to group it by the city. Then we're going to apply those summary functions, the mean, the sum, count, the n, using the summarize function, and we will get 3 rows here, okay? And so we're going to change our unit of observation from this entire table and each 6 rows into basically 3 things here, okay? And so here, I'm going to just take pollution, and I'm going to pipe it into the option, or into the function group by. And I'm going to say group by city. And when you do that, it doesn't look like anything has happened. So this is pollution. If I look at pollution, it looks like this. And if I pipe pollution into group by, group by, and I say city, it doesn't look like anything has happened. Okay? It looks exactly the same, except there's this key thing that here says groups, city, and there's 3 groups. So dplyr recognizes that there are 3 groups now. And then now I can apply summarize here. So I'm going to take pollution. Once I've grouped it, I can apply summarize. And I'm going to summarize by creating a mean column, mean, which is mean of the amount. And we'll do standard deviation. Is that what we want? Oh, I guess sum. Okay, we'll do sum of the amount, and we'll have n, which is n. Okay, yeah, question?
Can you do a keyboard shortcut for the pipe operator?
Control-Shift-M or Command-Shift-M, okay? Okay, and so what this will do is it's going to create the summary table based on group by. All right, and so here we've got the column mean, sum, and n, and it indeed has grouped by city, Beijing, London, and New York. If I run this before the pipe, so if I just pipe pollution directly into summarize, what will happen? I would just have 1 row. This is the sum of everything. I would have 6, and I only have 1 mean value. Okay, so by piping it into group by first, I'm changing my unit of observation into the city, and then I'm getting 3 rows back in my summary table. Okay, and so this is that demonstration right there. So we've got New York, and we are grouping it by the cities. Okay. I don't know what's going on here. All right, and so again, I can just take the pollution, apply the groups. We got New York, London, Beijing, and then if I just say summarize by the mean amount, it just summarizes these values, 22 and 16 and 19. Okay. Here I can group by a different thing. So instead of grouping by city, I can just say pollution group by size. Okay. And so here we have 2 groups. And so now I can pipe this into another summarize function here. And I could say give me the mean number of large particles, give me the mean number of small particles. So here we are grouping by size, and so we're only going to get just 2 rows here. Okay, so that's not a huge surprise. If you have a group and you want to get rid of the groups, you can apply ungroup. Okay, so if your current data frame, so if for whatever reason, so right now I haven't modified pollution at all, but I could do pollution. I'm gonna. So, oh, by the way, if you wanted to store the result of grouping pollution, you would do pollution and then pipe it into group by city, and then you would apply the or stick in the assignment operator here. Okay, and so this will take pollution, apply group by city, and then store this back into pollution. Okay, and then so pollution now has the grouping thing here. Okay, and so I can just do summarize pollution now that I've applied the and now that it has the group information stored in pollution, using summarize keeps that there. Okay, and if I again want to get rid of that, I can do pollution ungroup. Okay, and that gets rid of the thing. And if I want to store this back into pollution, I would do pollution and store that back. And so now pollution has no group information there. Okay, that's ungroup. You can further apply. Yes.
Will you run into the same problems as like Fred if you have like lower data in New York?
I'm sorry?
For group by, will you run into the same problem if like have something that's spelled as one of the cities?
Yeah. Group by requires the things be spelled exactly the same. So if I modify my pollution table so that the first entry is NYC like this, and I did group by pollution and I group by city name, it's going to create 4 groups because it sees Beijing, it sees London, it says New York, and it sees NYC, and it doesn't recognize that those are the and should be the same. Okay, and so it's going to think we've got 4 groups, and so if I then said summarize on mean, okay, it's got the summary for New York to be 14 particles and the summary for NYC to be 23. So that's no good. Okay. So yes, it is sensitive to all of these things. So here's a thing where we have grouped by country and year. And I don't know if you guys can see this table, but here we've got Afghanistan, Brazil, and China. Okay, and we have year, and then we have the sex. So here we've told it to group by country and year, and so this creates 2 tiers of groups. Okay, so we first grouped by the country, which is the blues, and then for Afghanistan, the greens for Brazil, and the grays for China. Okay, but we've further grouped that by year, and so we have the light blues for Afghanistan 99 and dark blue for Afghanistan 2000. We have light green for Brazil 99 and dark green for Brazil 2000, and light gray and dark gray for China 99 and China 2000. Okay, and so if I run summarize on this, group by country, year, and then summarize this, it's going to summarize the Afghanistan 99 and say you've got 2 cases. Afghanistan 2000, you've got 2 cases. All right. Brazil 99, you had a total of 4 cases, and Brazil 2000, you had a total of 4 cases. And China 99, you had 6, and China, this should say China 2000 is 6. Okay, so it's grouped these by this structure. We can further pipe this into summarize again, and then it recognizes that, oh, okay, I still have a tier of groupings here, and it will group the 2 Afghanistans together, the 2 Brazil rows together, and the 2 China rows together here. So you can create kind of a hierarchy of group bys, and the summarize will go 1 kind of one depth at a time. Yeah.
Oh, that answers it.
Okay. So if the first summarizes on all of the hierarchies you've created, and then the second summarize further groups those together. Okay, and then if you summarize that one more time, it would just collapse the whole table. So here, let's play around with flights just a tiny bit. Okay. So I'm going to do structure flights. This is our flights table. And so here we've got flights, the carriers. Okay, so I can take flights, and we can try to identify which carrier has the greatest number of delayed flights. Okay, or maybe we should say greatest proportion of delayed flights. Okay, so of course, so if we just did the straight up count of how many flights are delayed, the carriers that are the biggest, we're going to have the greatest amount, right? So maybe we want to do like carriers with the greatest proportion of delayed flights. All right, so how can we do something like this? So we're going to take our flights, and what do we want to do? So what we want to do is we're going to group by the carrier, okay? And so here we've got 16 carriers now. And so from here I want to summarize the carriers, and I want to figure out the proportion of flights that are delayed. So how can I figure out the proportion of flights that are delayed? So maybe we'll say departure delays, right? So they didn't get out. So basically we want to look at this column, departure delay, and we want to know if it is greater than 0, right? So if it's bigger than 0, then that means there was a delay, right? Or I don't know, maybe we want to say only departure delays longer than 10 minutes. I don't know. Right now we'll just say departure delay greater than 0. Okay, so we're going to group by carrier, and we're going to count the total number of flights. Or actually, I'm going to do mutate, and I'm just going to create kind of a yes or no for delay. Was it delayed, yes or no? Okay, because I don't think we have that information already in here. We have departure delay, but I'm going to create a new column, and this will just be delayed will be departure delay greater than 0. Okay, so here we still have this, and just to make sure that indeed this is working, I'm going to do select departure delay and our new column delayed. Okay, and so here we've got true, 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 and we have false, right? Okay, so I have delayed, so that seems to be working. So we've got our carrier, and was it delayed or not? And then we want to take the mean of delayed for each carrier, right? So if I take the mean of delayed, then that will give me a proportion of how many flights were delayed. Does that make sense? Okay, so I can mutate our delayed column, and we're going to create a new column called proportion, and this is going to be the mean of the delayed column. Oops. Oh, I'm sorry. I have to summarize. Not summarize based on our carrier, No, this didn't. It didn't like it. What am I have to do as.numeric delayed. What's that? Maybe I don't have, so I've got flights, we're going to group by carrier, we're going to create a column called delayed, and I want to summarize, and we're going to create proportion, and this is equal to the mean of the delayed column. And for some reason, I'm getting a bunch of NAs. I wonder if, oh, I probably have to do na.rm equals true. But this seems awfully high. Or I don't know. Does that sound about right? 50% of these flights are delayed, have a non-negative delay. Maybe that's true. We'll do a departure delay over 10 minutes. We'll see what proportion is over 10 minutes late. That seems like a lot, but I don't know. I guess we can just take a look at, and I can say flights. Well, this is we can do a quick check, right? So we can do flights, and we can do filter, where departure delay is over 0. Okay, and 128,000. That's a lot. And if I do flights where it's over 10,000, we get 82,000 out of 336. Just kind of a crude estimate. 83 out of 337. Yeah, about 25% of flights are over 10 minutes delayed, and I guess we get something along here. So what did I have? Mean here. Maybe we'll have a delayed proportion, and then we'll have n equal to n here. Total number here. Okay. Total number of flights, and so United Airlines had 58,665 flights, and 47% of those were delayed. It seems over 10 minutes delay. I guess we can check this ourselves. We can do flights. We'll filter to carrier is equal to UA. Oops. Oh, yes. Carrier, so we have 58,665, and we'll do departure delay, sorry, is greater than 0. Yeah, 27, so 58,665 flights, and of those, 27,000 had departure delays greater than 0. So this number is correct. About 47% of United Airlines flights don't arrive exactly, don't depart on time. So anyway, this would have been very difficult without dplyr, and you can do a lot of stuff with it. Okay, we'll end there, and Monday.